Okay. In this section, actually, or this chapter, we're going to talk about where the sine, cosine, tangent are positive and where are they negative. We have four quadrants. If you remember, this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. One, two, three, four. Now, we have a saying, a lot of people say, all students take calculus. A lot of people will use that. All students take calculus. That was the old saying. And I found out not everyone takes calculus. Engineers take calculus. But if you're an engineer, you don't take calculus. So I said, I need to come up with a different saying. So I came up with the saying myself, all, instead of students, all stores take cash. One time I decided, all students try Coke, and I meant Coca-Cola. And somebody jumped in. I said, what about crack? And I said, never mind. We're not going that direction there. You know, just like, what was that thing? Some old hippie. Something. I know, but, you know, it's just crack and tripped over acid or something. I don't know. That didn't sound like right in a classroom. So all stores take cash sounds like a clean one. And what does that mean? Let me talk about the first three trig functions, the sine, cosine, and tangent. The sine is positive here. The cosine is positive here. And the tangent is positive here. That's what that means. All three of them are positive in this quadrant. Now, out of these three, which one begins with the letter S? Only the sine is positive here. The cosine is negative, the tangent is negative. All stores take cash. T. Which one begins with T? Tangent is positive, these two are negative. Sine, cosine, tangent. All stores take cash. Cash, that's the letter C. Only the cosine is positive and the other two are negative. And that's one easy way to remember who is positive and who is negative in each quadrant. Now, we're going to extend that to the other three trig functions. There's a secant, cosecant, cotangent. So what about the secant, cosecant, and cotangent? Secant, cosecant, and cotangent. Let's talk about secant. Secant is 1 over what? 1 over the cosine. So if your cosine is positive, 1 over a positive number is what? Positive. I'll put them here again in case you forgot. Secant equals 1 over cosine. Cosecant equals 1 over sine. And cotangent equals 1 over tangent. I'll give you an easy way to remember that. It's always S and C together. So if you have S here this better be C. If you have C here, this better be S. They never match. It's never S and S and C and C. It's always S with C. So if you have S here, you have C here. If you have C here, you have S there. So that's if you decide, like, is it 1 over cosine, 1 over sine? If I'm talking about secant, it can't be over sine. It can't be the same letter. And if it's cosecant, it can't be the cosine. Again, it can't be the same letter. It has to be S with C. So here, the other three are also positive. Now let's look in quadrant 2. Since the secant is 1 over cosine, that's what secant. So if your cosine is negative, what is 1 over a negative number? Negative. And these will be positive. Nope. This will be what? Negative, not positive. 1 over a negative number. Cotangent is 1 over tangent. 1 over a negative number, that's a negative number. Cosecant is 1 over sine. Since the sine is positive, this is positive. Here, this is positive and that's negative. This is negative. Secant is 1 over the cosine. 1 over a negative number, that's negative. Cosecant is 1 over sine. 1 over negative, that's negative. Secant is 1 over cosine, that's positive. Cosecant is 1 over the sine, that's a negative. Cotangent 1 over the tangent, that's a negative. So all stores take cash. That's what you're going to hear me say a lot there. I'll stick with all stores take cash. All stores take cash. So all trig functions are positive here. When I say all, I'm referring to sine, cosine, tangent first. Because now here, you go, well, wait a minute. This begins with C. How can it be negative? I'm talking about the sine, cosine, tangent. Only the sine is positive. Only the tangent is positive. Only the cosine is positive. Once you figure these three, you can figure the other three. And here's what's going to happen. You're going to be given a problem saying to you, well, this is the tangent or this is the value. Tell me, what's the other one? What's the sine? What's the cosine? Now let's see. Let's take an example. We're at chapter 8. Now, if you want to know why the sign is positive in the first quadrant, why is it positive in the second quadrant, negative in the other two, if you're curious about that, well, if you think about the sign, when you go Pythagorean Theorem, like if you put an angle there, here's the reasoning behind it. When you're in this quadrant, when you're in this quadrant, quadrant 1, we said the sign is positive. Why? Because the sign is the opposite, which is the y value. The y value here is what? Y is positive here. The x value here is also positive. Remember, to the right, x is positive. To the left, x is negative. Up is what? Y is positive. Y is negative down here. And r is always positive because that's the square root. This is always positive. So the sign is what side? The sign is the opposite over the hypotenuse. Since y is positive and r is positive, what are you going to have? What's the positive over a positive? That's a positive result, right? The cosine is what side? The adjacent, which is x, over the hypotenuse. And x is positive and y is positive. Positive over positive, that's a positive. And what's the tangent? Opposite over adjacent. Still positive over positive, which is positive. That's why all three of them are positive in this quadrant. Now, when you're in the second quadrant, let me put this one up here. You have an angle here. The y value still above this line. Y is still positive. But the x value now is what? X is to the left, which is what? Negative now. And this is r, which is always positive. R will never be negative. So the sine, if you look at the definition of sine, it's the opposite, which is positive, over positive, and that's a positive. Opposite over the hypotenuse, y over r. The cosine is the adjacent, which is x over r. But x is negative and r is positive. What's negative divided by positive? Negative. That's why the cosine is negative in this quadrant. And the tangent is what? Tangent is going to be opposite, which is y over x. Positive over negative. And the result will be what? Negative. So only the sine is positive in that quadrant, but the other two are negative. And I can repeat the process for the rest of them. In this quadrant, when you're in this quadrant, x is negative and y is negative. Both are negative. R is positive, because you have to go something like this. The x value is negative, the y value is negative, r is positive. And again, the sine is y over r. Negative over positive, that's a negative. The cosine, it's x over r. That's a negative. The tangent, y over x, opposite over the adjacent. They're both negative. What's a negative by negative? Positive. And we can do the other quadrant, but you get the idea. But that's the reason why all of them are positive. Only the sine, only the tangent, only the cosine here. For homework, you're going to get some questions, and the question will be just straightforward. The question will be asking you, in which quadrant? Identify the quadrant. For example, sine of theta is greater than 0, and secant theta is less than 0. Which quadrant? Again, I have to go back and say all stores take cash. All stores take cash. Sine, cosine, tangent, all positive. Sine, cosine, tangent, negative, negative, positive. Here, sine to practice, cosine, tangent. Only the tangent is positive. These two are negative. That's the cosine's positive. Sine, cosine, tangent. All stores take cash. That means secant, cosecant, cotangent, all positive. Secant, cosecant, cotangent. Now the sine is positive. Cosecant is 1 over sine. That's positive. The rest of them are negative. The tangent is positive. That means the cotangent will be positive. The other ones are negative. Secant is 1 over cosine. That's positive. Cosecant is negative. Cotangent is negative. So when you have that chart in front of you, you go, I want it where the sine is positive, secant is negative. Which quadrant? Quadrant 2. The answer for that is quadrant 2. Make sure when you number them, you know this is 1, you know this is 2, you know this is 3, you know this is 4. And when they ask you which quadrant, don't write the number 2. They want to see I. When they say 3, you want to see I. When you try quadrant 4, that's I and V, capital letters. Write them that way. Not 1, the number 1, the number 2, the number 3, the number 4. That's the format they wanted. People ask, why they go 1, 2? Why not 1, 2? Remember, this was discovered by Greek mathematicians. A lot of Egyptian mathematicians did some work on algebra and math. The name algebra came from Ali Jabra, Middle Eastern mathematician. So when they wrote the stuff in the Middle East, they write right to left. Greek, they go right to left. So they have the chisel in the left hand and the hammer in the right hand. So you always go right to left. So that's why these are written right to left. You know, 1, 2, 3, 4. Because we could number them anything. I could call them 1, 2, 3, 4 for crazy numbering. But that's the reason why when we did them at that time, that's the notation we used. Now let's try another one. You might be asked this question. Determine the trig functions. Notice it doesn't say which function. Trig functions. What does that mean, the trig functions? It doesn't say sine, cosine, or tangent. What are they looking for then? All 6 of them. When they don't give you a specific one, you need to find all 6 of them. Of theta if the terminal side passes through the point, I don't know, -1 comma the square root of 3. That point tells me which quadrant I'm in. -1 comma 3. So this is -1 right here. Go 1 to the left, and 1.7, that's what square root, somewhere there. The terminal side is right here. So this point here is -1 comma the square root of 3. So if you make your triangle here, this is 1, that distance is 1, and this is what? Well, actually -1. Negative means you're going to the left. And this value is what? Positive the square root of 3. Again, can I find what this side is? This side is C. Pythagorean Theorem says C equals, or C squared equals A squared plus B squared. C squared equals what? -1 squared plus the square root of 3 squared. That's a 1. That's a 3. C is always positive, will never be negative. I know when you take a -2 and square it, that's a 4. But the length of this side, it is a positive value. It's always a +2. So what's the sign? We said it's the y value over r, the opposite over the hypotenuse. Y is what? The square root of 3 divided by 2. Cosine. The adjacent, that's the x value. The adjacent x over r. X is negative or -1. This is 2. That's -0.5 or 1/2. The tangent. Opposite, which is y over x. Square root of 3 over -1. Negative the square root of 3. Secant. Secant is 1 over cosine. This is your cosine. Flip it. R over x. R is what? 2. X is -1. That's a -2. Cosecant. Cosecant is 1 over sine. You take your sine and flip it. R over y. R is 2, y is the square root of 3. We don't like to see a square root. You multiply the top and the bottom by the square root of 3. To the square root of 3 over 3. And the last one is what? The cotangent of theta, which is 1 over tangent. Where's my tangent? Right here, y over x. 1 over that, x over y. X is -1, y is the square root of 3. Multiply by the square root of 3. negative the square root of 3 over 3. Now let's see if we are right. Let's do a quick check here. We said the sign should be positive. Is my sign positive? Check. My cosine and tangent should be negative. Cosine is negative, tangent is negative. Check. Secant. Secant should be negative. Cosecant should be positive. And the cotangent should be what? Negative in that quadrant. So all my signs are check, 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 check. I have the correct sign. The only time we could get in trouble, the only time, is when the angle lands on one of those axes. If the angle lands on the axes, then we got to pay attention to it. So what does that mean? If the point on the x-axis, y-axis, if the point is right here on the x-axis, right there, I'm just doing some points there. What will happen here? The cosine will equal to 0. But the sine of 0, cosine of 0 equals to 1. Oh, not 0. But the sine of 0, that's equal to 0. Which creates a little problem for us, because tangent is what? What's the tangent? It's sine over the cosine. Sine is 0, cosine is 1. What's 0 over 1? 0. What is the secant? Secant is 1 over the cosine. If the cosine is 1, what's 1 divided by 1? 1. Here's the headache. The cosecant. The cosecant is what? 1 over sine. What's 1 divided by 0? 1 divided by 0? Does not exist. Can't divide by 0. 0 on the bottom is a problem. And the same thing with the cotangent. Cotangent is 1 over the tangent. Your tangent is 0. 1 divided by 0 does not exist. So when you're on the x-axis, y-axis, it's a different story there. When you're on the y-axis, x is 0, that's the cosine, but the sine is 1. That's points like these. Again, tangent is sine over cosine. Which is 1 divided by 0, and that does not exist. Can't do the tangent of 90 degrees. If I try that on my calculator, it's going to give me an error. Here we go. Tangent, 90 degrees. Error. Can't be done. Because you're dividing by 0. Secant, it's 1 over cosine. Cosine of 90 is 0. What's 1 divided by 0? Does not exist. Cosecant. Cosecant is what? 1 over sine. 1 divided by 1, which is 1. And the cotangent of 90 degrees, cotangent is 1 over tangent, which is cosine over the sine. Because the tangent is sine over cosine, that's cosine over sine. What's the cosine of 90? 0. What's the sine? 1. What's 0 over 1? That's 0. Quickly here, I'll just do 2 of them and you can derive the rest of them. The sine is 0. The cosine is negative 1. And you can figure the other ones by going tangent sine over cosine, which is a 0. If you're down here on the y-axis, down there, here the cosine is 0, that's 270, and the sine is negative 1. So if you know with the sine, the cosine, you can figure the rest of them. Okay. Let's see, anything else from that section I need to cover? It looks like that's it. I'll stop the video.